So as we saw, IITM and IMD have developed their own multi-model ensembling system with the same dynamic core of the CFS, but different configurations, various coupled, uncoupled, and spatial resolutions. So here it is doing some idealized forecast experiments, phase-wise evaluation of the multi-model ensemble, which is that GFS, CFS, T382, T126 combination that we looked at before. A shows MISO forecast skill as a bivariate correlation coefficient with forecasts initialized from days clustered in active phases, so you're transitioning from active to break, and break phases where you're going from break to active, and all phases. So you can see that there is definitely skill out to more than 2 weeks if you consider 0.5 correlation as BVCC as a threshold where the forecast is useful. B shows the same skill for ensemble means of individual components. These results are based on 2003 to 2014 hindcast runs for CFS T126 and CFST 382, GFST 126, and GFST 382 models. So essentially the same model in coupled, uncoupled, and different configurations. And you can see essentially that multi-model ensembling increases the skill, which is consistent with what we have learned everywhere. And a well-calibrated forecast system would have RMS reduced and skill increased, and they should be the same thing when the model is perfectly calibrated. So that can be seen by looking at this kind of BVCC formula, which is A1 and A2 refer to observed MISO 1 and MISO 2 time series that we talked about. By the way, maybe I didn't say it clearly, but the definition of that MISO index, the phase diagram that we saw, is a extended EOF of the rainfall averaged over the over a certain core monsoon region. And people debate about whether that's the best way to do it or not, but nonetheless, here B1 and B2 are the respective forecasts for time T for a lead time of tau days. N is the number of forecasts. So you are taking N number of forecasts of MISO 1, MISO 2, and forecasts at lead time tau. Okay, and finding the bivariate correlation between observations and the forecasts as a skill measure. So BVCC of MISO indices for CFS T126, so the various configurations, I won't read all of them, but we are looking here at 2013, 14, 15, and 16 for these various configurations, coupled resolutions, uncoupled resolutions, so bias corrected SSTs being fed, and so on. So again, you see the spread here, and you see useful skill out to more than 2 weeks, which is kind of confirming what we saw with these idealized forecasts where they were just done by combining hindcasts from the past. Okay, here are specific years being looked at. So we can look at RMS error again, A1, A2, and so observations and forecasts, essentially at lead times tau over ensemble or forecast numbers N realizations. And you can see the same figure here for various configurations, and you can look at the RMS error. So above 0.5 here, again out to 16 to 18 days, and you can see the ensemble spread for individual configurations versus the multi-model ensemble and the RMS. So the idea is that the RMS is increased and the ensemble spread is increased when we do multi-model ensembling. Both indicate an improvement in the model performance in terms of reduced RMS, increased ensemble spread, and increased skill. So this is the advantage of doing multi-model ensembling, and this is here, it's called multi-model ensemble, but it is the same dynamic core, different configurations of the same model. Okay, Let me lead that to the next, where once you have this kind of skill for MISO, okay, MISO doesn't necessarily tell you spatial distribution of the rainfall, and now people are demanding more and more high resolution spatial predictions. So now we are looking at the same configurations, including the multi-model ensemble, comparing it with deterministic skill score. So you take one reference run and compare against that skill, with weekly lead prediction of area average rainfall with observations for hindcasts over 2003 to 2014 over the homogeneous zones of India, which are the Northwest India, Monsoon Zone Index, Northeast, Central Eastern India, and the Southern Peninsular India. So we are now looking at skill at regional level distributions. MISOS doesn't tell you that, so you have to go and take the model and do skill assessment in its regional distribution. So you can again see that systematically, maybe so when you do S2S, as we said before a couple of times, you typically don't try to predict a single day on beyond a week. What you do is you tend to average over a week. So here are averages for week 1, week 2, week 3, and week 4, and that skill tends to be higher. So you may not be able to predict a specific rainfall event on day 8, but from day 17 to 14 the skill will be good. This information is very useful for water resource management, agriculture, irrigation management, and various other things. Okay. So looking again at bivariate correlations for the various regions, you can see that monsoon zone, there is skill, and multi-model ensembling increases it in week 1. Skills drop in week 2 and so on, but multi-modeling still increases the skill marginally, and it's still above 0.5. Even in week 3, maybe it's marginally useful. Same for Northeast India and Northwest India, but Southern Peninsular India has very little skill, and here also skill drops off in week 2 compared to these other regions. Okay, so there is still useful skill here in week 2, but this really has no skill at all, even in week 1, let alone week 2, 3, and 4. So this spatial distribution of skill has to be understood as well. In the next podcast, we will look briefly at even smaller scales. Homogeneous regions are large scale still, and as you can expect, when you aggregate over space, skill goes up. When you aggregate over time, skill goes up. But people demand skill even at the so-called taluka levels, which are administrative units. They are called blocks in India of the order of 1 degree by 1 degree. So how does skill vary by region when we look at that 1 degree by 1 degree level of rainfall distribution at active break time scales? That's the next challenge that we will look at briefly. Okay.